Hello everyone. In today's session, we will be starting with something new, and that is various forms of equations of a line. Now, in my last lecture, I had mentioned that line is nothing but locus, and we know how to write equation of locus now. So, we are expecting some xy equation for describing a line. Now, there are various forms. Let me start one by one. First is slope intercept form. When I say slope intercept form, means slope and intercept, two things are given to me. So picture would look something like this, where inclination theta I am showing, because I cannot show slope. Slope m is tan theta, so it would be a number which cannot be shown in the figure. But I can always show angle theta, which is inclination. So theta I can show in the picture, and C is y-intercept, means where line meets the y-axis, that point's distance from the origin. That is nothing but your y-intercept. An equation of such a line where m and c are known to me is given as y equal to mx plus c. Mind you please, this is the most easiest form of equation of a line, or rather I should say most favorite form of me. Now, why do I like this form? Reason is that if you know m and c, some rough sketch you can surely draw. If you know m, if it is positive, then you will be drawing a line which makes acute angle with x-axis, correct? And if you have negative slope, then you will be drawing a line which makes obtuse angle with the positive x-axis. And if suppose you have understood that you have to draw a line which makes acute angle, but then where to draw that line? If your C is positive, then that line must meet above x-axis, correct? So picture would be something like this. If C was negative, then I would have drawn that line below the x-axis so that its y-intercept is negative. I hope you are getting me what I am saying. Just by knowing C and M as numbers, negative or positive, you should be able to sketch some rough sketch. My request to each and everyone, the one who is listening this video, is that you should get hold on drawing figures also. Once you know how to draw figure, your coordinate geometry problems get solved like anything. So please try and draw the pictures, and for drawing pictures, something like this is required. That information about M and C are known to you, you are in position to draw the picture. Y equal to mx plus c is the description of the line for this case. Now, what you understand is that if I have to apply this, then in place of m, I will be writing 7 if slope is 7, and if intercept is c is 5, then I will be writing in place of c as 5. So equation would look like y equal to 7x plus 5. See, now m and c, they would be replaced by numbers. So you should not get perturbed with the formula. Y equal to mx plus c is a standard form where m and c would be replaced by the given numbers given in the problem. Okay. Also, further application of this is line which passes through origin. And in that case, your C would be 0. So equation of such a line which passes through origin is given as y equal to mx. So in question, in problem solving, anywhere line passes through origin, if this comes, you should be immediately in position to think that its description would be of the form y equal to mx. Correct? Proceed from here to the next. And next type is point to slope form. Name only suggests that we are expecting one point on the line and slope would be given to me. Mind you please, in both the types, what I am observing here is that two things are given to me, right? Why two things are given to me? Like, stretch your mind and try to get answer for that also. Like in plane geometry, you have seen through one point, infinitely many lines can be drawn, but through 2 points, only one precise line can be drawn. That means whenever you want to draw a line, two things about that line should be known to you. Like 2 points in plane geometry, here we are seeing slope and intercept given in one case and slope and point given in the second case. And picture would be something like this, that x1, y1 is a point on the line. And now again, slope I cannot show in the picture, so I show inclination theta. And then I should be in position to write the equation. And equation is y minus y1 equal to m into x minus x1. This is the standard form. x1, y1 would be given to you in the problem, m would be given to you in the problem, and then you can substitute. For example, if a line passes through 3, minus 4 and slope is 1, then in place of m you will substitute 1, in place of x1 3, and in place of y1 minus 4. An equation of line would look like, finally on simplification, x minus y minus 7 equal to 0. I hope you have understood how to write those quantities x1, y1 and m in the formula. Proceed from here to the next type. And the next type is 2-point formula. 2-point form also people generally start with. I mean, choice is yours. Finally, all forms you are expected to remember. 2-point form means now you are expected to know 2 points on the line. Means x1, y1, x2, y2 are given to you. And some point P, a moving point on the line I have shown as P, and its coordinates I am writing as x, y. Now, how to write equation if someone thinks that from where I am writing those equations, how do we know from where they have been derived? Then at least in this picture I can tell you something as that slope of AB and slope of AP and slope of BP, they are same, isn't it? Because those 3 points are collinear. And if that is the thing, then you should be in position to write slope. And how slope you would be writing? Using the formula slope of a line joining 2 points, y2 minus y1 upon x2 minus x1. Using that also you could have written. So y2 minus y1 upon x2 minus x1, this is the slope of AB. And y minus y1 upon x minus x1, if you look at it as this, then y minus y1 upon x minus x1 would be nothing but slope of PA. So slope of PA equal to slope of AB. Had you used, you would have got that same equation. So y minus y1 equal to y2 minus y1 upon x2 minus x1 into x minus x1. This is a standard form of the equation whenever 2 points on the line are given to you. Okay. So take one example before I proceed from here. Take 2 points as say 0, minus 4 and minus 6, 2. Then what would be equation of the line? Equation of the line y minus 4 equal to, substitute y2 minus y1 upon x2 minus x1. That would be 2 minus 4 upon minus 6 minus 0 into x minus 0. Simplify it, that would lead to x plus y plus 4 equal to 0. Right? This was simple application. How do we use that formula? Proceed from here to the next, and that is intercept form. Now again, I am writing intercept form, but I am expecting both the intercepts should be given to me. Why? Because a line would be completely known if 2 things about that line are known to me. So 2 intercepts I am showing in the picture as A and B. And what would be equation of a line if 2 intercepts, x-intercept as A and y-intercept as B, given to me? Then equation of the line would be x upon A plus y upon B equal to 1. Now in all the forms, whatever I have discussed by now, you must have observed one thing. All the equations have single degree term of x, single degree term of y, right? And a constant. Whether it was y equal to mx plus c, or whether it was y minus y1 equal to m into x minus x1, or even this form, or in the 2-point form. Everywhere you get a single term of x with degree 1 and term of y. There is no product, there is no square in the equation. So actually this is the easiest, entity of coordinate geometry to understand. So everywhere you are given 2 things, and my new observation is equation is always in terms of x and y with single degree and a constant. Okay. Now take one example as equation of a line, and it has intercepts, x-intercept as 4 and y-intercept as say minus 3. Then what would be equation of the line? X upon 4 plus y upon minus 3 equal to 1. Simplify it, you get 3x minus 4y equal to 12. Again, see what I said is again here applicable. Single degree term of x, single degree term of y, and a constant. Okay. And the next form is normal form. And this is very unusual form. Like here, something very unusual is given. What is given is line AB is such that its perpendicular distance from the origin is given to you, and that is P, and that perpendicular makes angle alpha with x-axis. It's very unusual information. But again, as I said, 2 things are required. So 2 things are known to me. So I must be in position to write equation from here. Now, those who are not interested in the derivation part, they can straight away remember the last thing what I say. But those who are interested in knowing that how that final form must have come, for them, I'm writing here certain things. That line's inclination is 90 degree plus alpha. And also that point P, which is foot of the perpendicular, it is P cos alpha, comma P sin alpha. What I tried to do here is that I can write slope because inclination is 90 degree plus alpha. So slope would be tan 90 plus alpha, which would be minus cot alpha. So slope is known to me. A point on the line is known to me. So I can straight away write slope point form. And from there, if I write equation of the line, finally, it would turn out to be, on simplification, x cos alpha plus y sin alpha equal to P. So this is the standard form for normal form. So x cos alpha plus y sin alpha equal to p. What are alpha and p? P is the perpendicular distance from the origin of the line, and alpha is the angle what that perpendicular makes with positive x-axis. Now, if you want to take one example I can take as that we have to find that perpendicular distance 4 and with inclination 60 degree equation of the line. And answer would be x cos 60 degree plus y sin 60 degree equal to 4. Mind you please, I'm not writing now cos 60 degree value and I'm not writing sin 60 degree. If I write that, then it would look like normal equation only. Since I wanted that line equation to be in the normal form, so I'm leaving answer as x cos 60 degree plus y sin 60 degree equal to 4. Okay. So in all the forms, whatever 5 forms what we learned, one common thing I have seen, as I said, that you have single degree term of x, single degree term of y, and a constant. So let us take one general form of equation of a line. And it is always of the form ax plus by plus c equal to 0, right? And that goes without saying that a and b both cannot be 0 simultaneously. Otherwise, nothing would remain there, right? I hope you understand that. So a and b, why not 0 together? Now, ax plus by plus c equal to 0 always represents a straight line. And certain more things you can understand about it. That if ax plus by plus c equal to 0 is given to you, can I write slope of the line? Can I write intercept? For that, I am giving you separately list of formulae. Frankly speaking, those who have understood first 5 forms, any one form you stick to and you would be in position to write all these things what I will be writing here. Slope of the line is minus a upon b. X-intercept is minus c upon a and y-intercept is minus c upon b. If you rewrite that equation, ax plus by plus c equal to 0 as ax plus by equal to minus c, divided by minus c everywhere, then you will be able to write x upon minus c upon a plus y upon minus c upon b equal to 1. And that will give you x-intercept and y-intercept. So, those who understand how to write intercept form, they will be able to actually change this equation in intercept form. And from there also, you can get x-intercept and y-intercept. Or if you wish, you can remember them as formula. Choice is entirely yours. I think this is good enough for this particular session. Hope you enjoyed the session. If you have liked the video, please click to subscribe on this side. And if you want to place the order for the book, please click on this side. Thank you.